Alrighty, so I know I didn't give you guys much time to practice these two. Maybe what we'll do is come back to these if we have time, but I'll just tell you the answer. Oh good, Aspen and Destiny, you guys got it. It's A. Excellent. Yep, the length of segment GD is 3. Okay, how about this one? Give this one a shot real quick. We'll take like 1 minute, so do it super fast, as fast as you can. And hopefully it'll make sense to you. I put the two transversal proportionality corollary up here as a hint. So 3 or more parallel lines divide 2 intersecting transversals proportionally. Now it should indicate here that these are parallel. You're supposed to assume that they are, which I don't like, but these are parallel. So PL, let's put the arrows on there. We'll do that. There we go. Hey, Safa. We have a small class today because everybody's out testing. Except for those of you that are done already, or maybe have not done it yet, but I know Colton, Destiny, and Sarah have already done theirs, so they're done. Okay, give this one a shot really quickly. Nice job, Destiny. Do you want to show us on the whiteboard, Destiny, how you did that one? You got the answer right. Would you be willing to share that? Oh, good, Safa, you're done. Awesome. How did it go? Did it go well? Not too bad, or were there some questions? Because I'm interested, because this is the first year you guys have actually been tested on geometry, right? Like the actual class you're in. Prior to this, it was your grade level. So do you think that was easier? Because hopefully the stuff was more familiar, right? Was there still some stuff that we haven't gotten to yet? I think that'll be the point of the, because you're going to have one now and then you'll have another one in May. Kind of okay, but not super great. Yes, that's true, Sarah. I know. It is hard to remember some formulas. Most of it, though, you at least looked at it and you're like, well, you did go over that. Was there some stuff that there were some formulas given? Yes, and then some that weren't. Okay. And then were there some items where we haven't gone over at all yet? Oh, no formulas were given for you, huh, Sarah? Hey, well, that's a good way of thinking also. So if you guys, I know we're kind of talking about testing and this question at the same time, but Destiny said, well, she sort of cheated, but it does make sense, and it does actually follow from proportionality. She said, I looked at the lines and saw that LE was shorter than PA, and 2.5 was the only one short enough to be correct. So, I mean, that would work in a sense as long as it's drawn to scale. Usually they do try to draw it to scale. Occasionally they'll throw you off in that way, though, so you have to be a little bit careful about that. But, okay, really quickly then what you would want to do, if we label PA, okay, so we know that that's 7, PR, all the way from here to here is 21, which would mean that from A to R has to be 14, right? So if you know the whole distance is 21 and you know from P to A is 7, you subtract these two numbers, and then from A to R has to be 14 because 14 plus 7 adds up to the 21. Okay? And then PR, so we have PR, ET is 5. We want to know what the segment LE is, so we'll put an X there. So you could set up the proportion like this. 7 over 14 equals X over 5. Cross multiply and solve. Okay, and D is the correct answer on that one. All right, so if you guys are just popping in, welcome. We have kind of a small class today because I think everyone's out. Well, not everyone, because obviously you guys are here, but a lot of our class is out for testing. But we were just reviewing a couple questions there for the Unit 3 test. So, like I mentioned at the beginning, this will be the last Class Connect for a while because I'm going to be out Friday and all next week. However, we are going to have everything covered that you'll need for Unit 3. So we're going to do 3.11 and 3.12 today. 3.13 is your Unit 3 review, and then you have your test. So already posted on the left-hand side of the class, under Class Connect recordings, you will see the Unit 3 review. Okay? So check that out. I will also put it in the chat right now for you. Yes, you know what, Brian, I bet you I'll see you there because are you testing in Pueblo? That's where I'm going to be. Friday's my first day too. Yes, yep, I'll see you there. That's where I'll be too. Awesome, cool. Okay, so there's the link for the Unit 3 review, okay? So you'll want to check that out for your Unit 3 test. Yes, I think it's 3.14. Let me double check really quick. I think 3.13 is the review, and then should be 3.14 that is the test. Yes, that's right, Keely. Yep. Am I going to see you, Keely? Are you testing at CSUP? And then, other exciting news, I think, for you. You probably already read this. I'm going to excuse the Unit 3 Part 2 test. Oh, no. Okay. Maybe you're going to like Alamosa, or it might be something down south. Oh, Brian, I thought you'd be disappointed. Yeah. Okay. So last time I mentioned that I was going to have you guys take it, but I'm just going to excuse it for you guys this time because I feel that, well, just with testing and everything going on, I think you guys will need the break. And then also, I just feel like a lot of this, you know, sometimes I feel like the stuff on the Part 2, we don't cover a lot on the Part 1, and so, but with this Unit 3, I feel like things are covered pretty well on the Part 1. So I think if you do okay on the Part 1, you're going to get what you need out of Unit 3. So I think we're going to be just fine to excuse that Part 2 test for this time. Okay? All right, so that's why it'll be hidden. You won't see it. So just do the Part 1, and like I said, access this recording before you take that, and that will help you review for it, okay? Yes, you're welcome. Okay, so 3.11 and 3.12, we're going to cover area and volume ratios. So we're going to use ratios of areas and ratios of volumes to find the scale factor that relates figures together. Okay? Yes, I am glad you did. I thought you'd probably be excited about that. All right, so 2D scale factors. This is 3.11. So 2D is referring to area. Okay, what you want to do, we're going to make a ratio for similar figures. The key thing, remember when we talked about T? Do you guys remember what we called T? It's on the board. There's a hint on the board if you read ahead. No, time, yeah, well, in some formulas it does represent time, but not in this case. It actually doesn't start with a T, so it's a little bit tricky. Yes, okay, so it represented the ratio of the sides. Right, and we call that scale factor, so it's right here. But you guys are right, yes, it is a ratio. So T is a ratio of the sides, okay? So we call it scale factor, so T is like side 1 over side 2. Okay, it's a ratio of the sides. And we call it scale factor. Okay? Give me a smiley face if you recall doing that. You might not remember it perfectly, but does it sound familiar? Do you remember that we did go over it at some point in this class? Yeah, okay, well, that works. Okay, we'll talk about it quite a bit today. Okay, so this is a very similar idea, no pun intended, but you're going to be doing areas. You're going to make a ratio with the areas, and because the areas are a two-dimensional amount, we're going to say that that's equal to the scale factor squared. Okay, so if you knew that these two rectangles were similar, and you wanted to find out what the scale factor was, and you knew the area 2 and you knew area 1, you could make a ratio out of them, set it equal to t squared, and then you can square root if you wanted to find t. Okay, and we'll do that in a minute. But here's an example. Okay, so this question says, what is the scale factor between these similar triangles? So it tells you that triangle DEF is similar to triangle ABC. It gives you the areas of the two triangles, so you can know that this formula is true. So this applies if the figures are similar. Okay, so you can make a ratio with the areas. Now, as a side note, the formula that I'm giving you here does say A2 over A1. However, it depends on the way the question is worded. So in this particular question right here, it doesn't indicate, it doesn't give us, we're not going to be incorrect by doing area 2 over area 1. Sometimes, though, the way the question is worded or the way the information is given to you, we might need to do area 1 over area 2, and that would also be equal to t squared. It depends, okay? And I don't know if you recall, but when we talked about scale factor, it was the same idea. It depended on if you were contracting or expanding, okay? So you're going to have to put on your thinking cap and think about your question and see if that is going to matter in your particular case. Here it doesn't, so we're okay to just put this area over this one. Okay, so we made a ratio out of the areas. Set it equal to t squared. Okay, so to get the 2.25, you simply divide 67.5 by 30. You get the 2.25. And then to get to the last line, what they did was they square rooted 2.25 to get to 1.5. Okay, yeah, exactly, Tristan. Yes, depends on how hard they want to make your life, right? That's right. We'll try to go through some. Okay. All right. So here the question says, find the scale factor. What's the scale factor? Let's stop with that. What are they wanting you to find? What's represented, or what do we call scale factor? Okay, you guys are super close. Tristan and Ryan, you guys are totally on the right track. You're not quite there, though. Scale factor is, you'll get there by doing area 2 over area 1. And it's related to t squared, but it's not t squared, it's just t. There you go. Yes. Okay, so we're looking for t. We just want t. Okay, so that's our ultimate goal. So we're going to find t, or the scale factor, used to transform trapezoid HIJK to create trapezoid LMNO. So see there? They're telling you in this problem how you need to set it up, because we're going from this trapezoid, which is the bottom one, or the larger one, to LMNO, which is the smaller one. So let's think about this. We can actually cross some things out right now without doing a single thing. If we're going from a larger shape to a smaller shape, what kind of numbers are going to do that for us? If you're going from larger to smaller, yeah, A and D would be good choices. Yes, Nora, less than 1. Very good. So our t value is going to have to be between 0 and 1. So not B, not C. We can cross those off right now. Okay? So that will give you a hint. Now let's say that you're still like, okay, well, I understand that part. I still am a little bit confused whether I'm going to do 21 over 84 or 84 over 21, okay? Well, look at those two numbers. Well, actually, let me back up even before that. Maybe you're going, how did you even get 21 over 84 or 84 over 21? Well, that's from the ratio. So you can either do area 2 over area 1 equals t squared, or, depending on how the question's worded, you might need to do area 1 over area 2 equals t squared. Okay, so it just depends. And that's where I'm getting these. So this is area 2, 21, okay? 84 is area 1. Okay, good, Tristan. Why do you think it's this one? You are correct. This is the one we want to use in this case. Just take a look at your numbers. What kind of a number would you get here? Would you get a number between 0 and 1? You can see that if your number is smaller on top than on bottom, you're going to get, yeah, good. You're going to get 0.25 or 1/4, or either, whether you write it as a decimal or a fraction, that's a number between 0 and 1. Good. Okay. Now be careful, Sarah. That, I know that you are not the only one thinking that right now. Okay. I know that you're not. See what Sarah wrote? She said, okay, it's A. Because you guys are right. Okay, so it's equal to, we're going to do 21 over 84 equals t squared, and you are correct. If I reduce that, it reduces to 1/4. Is that t? Because remember, that's what we want is t. Okay, right, but I am so glad you said that, Sarah, because I guarantee you that is the #1 place you guys are going to mess up on this. Okay, because students do this every single year. They reduce the fraction and say, okay, that's the answer. Choose my answer, move on to the next question. Right, Tristan, we have to square root first. So just be careful not to forget that. Hopefully, poor Sarah, she was my guinea pig. But I really, I love it when you guys make mistakes in here because there's no consequence, right? This isn't the actual quiz yet. And when you get to the quiz, you're going to remember it. Okay, good, Sarah. I'm glad you're a good sport about it. So we're going to get t, and then 1/2 is actually the square root of 1/4. Okay, right, Keely, absolutely. So you want to reduce it as much as you can, okay, and then write that answer there, and square root to get just t. You have to get rid of the little exponent of 2 there, which square root and square are opposite operations, okay. Now, I know this is a little confusing too when we get to fractions. You're like, how is 1/2? 1/2 is bigger than 1/4. So how does that work? If you square root 1/4, how do you get 1/2? Well, just think about mathematically what you're doing. This means that 1/2 times 1/2 would equal 1/4 under here. So the number that you get out of the square root, if you multiply it by itself, you should get back to this number that's underneath the square root sign. Okay, so just keep that in mind. Also, yeah, it doesn't really seem intuitive. I agree when we get into fractions, but that is how it works. So just you can kind of double check yourself that way. Also, one thing you could do, you could use your calculator. Depending on what kind of a calculator you have, you could put your square root sign, parentheses, 1 divided by 4, close your parentheses, and that would pop out 1/2 for you. Okay. You could, now this gets a little more iffy. Now if it's a nice decimal that doesn't repeat, this will work. You could do the square root of 0.25 and your calculator would show you that it's 0.5, and then you say, oh yeah, that's the same as 1/2. Okay. It gets a little tricky though if you had 1/3 or something like that. I don't think they'll probably give you something quite that difficult. You never know, but probably on this they'll give you some fairly nice numbers that will have a good square root. Okay. Let's see. Well, yes. So good point, Brian. I'm glad you brought that up. So that's why the ratio is equal to t squared. The ratio of the areas is equal to t squared, not to t. So you're right, Brian. We can't take 84 and multiply it by 1/2 to get to the other area. It doesn't work like that because we're in a 2D scale factor. So if you knew one area, you would actually need to multiply that amount by t squared, which is the 1/4. So if we took 84 and multiplied it by 1/4, we would get back to the 21. The reason that, so if you did 84 times 1/4, you'd get the 21. And so if you knew one of the sides, for example, yes, it is confusing. It's, yeah, it depends on, and then in a second here we're going to do 3D, okay? So you can apply all these same ideas to 3D. I bet you guys will understand 3D now that we've talked about 2D, okay? But remember, scale factor is the ratio of the sides, okay? So if we knew one of the sides, like if we knew side HI, we'd multiply it by the 1/2 to get ML. Okay, so you got to keep all these straight. So T is the ratio of the sides. T squared is the ratio of the areas. What do you think T cubed is going to be? So we're going to talk about that here in a second. So T is the ratio of the sides, the one-dimensional amount. T squared is the ratio of the areas, which is a two-dimensional amount. What do you think T cubed is? Good, Brian. Because, yeah, once you make that connection, it's not so hard to remember it all. If you're just trying to memorize this, it gets super confusing. So you have to think through this. Okay, so in other words, I could write it like this. I could say T is the one-dimensional, so this is a 1D over 1D, okay? T squared is a two-dimensional amount over a two-dimensional amount. In this case, areas. Okay, area 2 over area 1. This is side of the second figure over the side of the first figure, or vice versa, it depends, okay? What do you think T cubed is going to be? So if I have a one-dimensional ratio for T, a two-dimensional ratio for T squared, what do you think T cubed is going to be? What kind of a ratio? Yeah, 3D. I'm going to be comparing 3D amounts. What do we call that? Not area. What's above area? What's a 3D calculation that we've been doing quite a bit of? Yeah, volume. There you go. Volume 2 over volume 1, or volume 1 over volume 2, depending on how the question's worded. Good. Do you guys see that now? So see how the T is just the one-dimensional ratio? T squared is the two-dimensional ratio. T cubed is three-dimensional ratio. Good. Okay, so here we go. See? You already knew the next slide. We don't even have to go over this now. This is 3.12. Okay, so that's why 3.11 and 3.12 are related, because it's really just whether it's T squared or T cubed. Depends on if it's area or volume. Okay? So T cubed, because you're making a ratio of 3D amounts, volume is 3D, you have a length, a width, and a height. And so that's how you can relate the volumes. It's going to be equal to T cubed. Right, Keely, exactly. So you have to read the question to see, okay, do I need the larger volume on top or on the bottom? Yep. Yep, and it just takes practice. Okay, again, just think though, like on this last problem around here, okay, it said we're going to transform trapezoid HIJK, which is the bigger one down here, to create trapezoid LMNO. So you wanted to go from something bigger to something smaller. And so that's why we crossed off B and C right away, because we knew, okay, well, if I'm going from something bigger to something smaller, I don't want to be multiplying by a 2 or a 4, because what that's going to do is that's going to take my larger figure and make it even bigger. So I don't want to, I know I can cross those off. Okay, so you have to just read the question to figure out, do I want to do 21 over 84 or 81 over, or 84 over 21? Good, good. You guys are getting this. You guys are thinking. Very good. Okay, let's give this one a shot. Okay, it says the volumes of two similar solids are 27 centimeters cubed. Okay, see that exponent of 3? That's a volume. Okay, and also it tells us volume, but even if it hadn't told you, you see that centimeters cubed, you know it's a volume. And 1,728 centimeters cubed. What is the ratio of the corresponding sides? So if it's asking for what's another way to say the ratio of the corresponding sides? What letter do we represent that with? Good, good, good. Yay, yay, yay. Look, good. I'm seeing lights going off, even though I can't see you. Awesome. Exactly. T. T is the ratio of the sides. Side 2 over side 1 or vice versa. Okay? Oh, hold on one second, guys. I'll be right back. See if you work on this one and see if you can get it now that you know. And I'll take it off of follow if you want to go back a slide, okay? Give it a shot. I'll give you a minute. If one or even more of you would like to start writing it up on the board, I would love that. Yay, Sarah's got it. You're the first one to put an answer in there, Sarah. Nice job. Let's see. So far, Sarah's the only one that has it. Very good. Very good. So Tristan, how did you know to do the 17, 28 in the top and the 27 in the bottom? Good, Sarah. Yes. Yes, see? Now you're not going to forget. Now you would actually technically say cube root it at the end. But yes, I know what you're saying there. Excellent. See? That's why I love it when you guys make mistakes, because then you don't forget that again. That's awesome. Good, good. So yes, all of these is like 3 over 1, 4 over 1, 8 over 1, 64 over 1. So you can see that pattern is the larger number is in the numerator, right? Excellent, excellent. So this is like 3 over 1. If you were to make these into fractions, this is what Tristan's saying. This is how he figured it out, which is great. Okay, so he said, okay, well, I looked at the answers, and all my answers, the larger number is in the numerator, and the smaller number is in the denominator. So I knew when I set up my ratio, I had to put the larger number on top, the smaller number on bottom. Do you guys see how to kind of read the question and also combine? Now, if this were like on a Part 2 test, and you did not have multiple choice, now again, for this unit, the Part 2 test is excused this year. But for you know, if it didn't have multiple choice, then it wouldn't actually matter how you set up your t value. You could either get good, I'm seeing more right answers now. You could either get you know, the like if the answer was 5, you could get 5 over 1 or 1 over 5, and as long as you showed your work, either one of those would be okay here, because it doesn't actually tell you, other than looking at the multiple choice answers, which way the ratio would be set up. Okay? So excellent. Okay, so you're almost there, Tristan, but not quite. So 64 is equal to what? So excellent job so far. Do you guys see what he's doing? I know there's a few of you left that haven't put an answer in. Are you guys following? Okay, it is equal to this, which is equal to this, right? We want the ratio of the corresponding sides. Is that t cubed? No, you're right. What's the ratio of the corresponding sides? Now be careful. Nope, you don't want to divide by 3, which I'm sure some of you did as well. See, I love this. When you guys get on a whiteboard, we just find all kinds, because it helps, because I know you're not the only one thinking like that. Yeah, okay, so what do we do? Okay, so it means t cubed, so let's write it. We have t cubed equals 64, okay? what we want to do, it actually looks like this. It looks like a square root except you put a little 3 right there. We call that cube root. So that means blank times blank times blank equals 64. So what times what times what equals 64? Yeah, which is, you know, that doesn't surprise me, Tristan. So see, we're getting challenged in all different ways here. You're right. You are right, Keely. Keely says it's 4. And that's right, because 4 times 4 is 16. 16 times 4 is 64. So 4 times 4 times 4 is 64. So good. Good. You guys got B. I see 5 of you that don't have an answer in there. Let's see. Well, Keely just didn't have a chance to get hers in. So 4 of you didn't have an answer in there yet. Does this make sense, though? If you didn't get a chance to put your answer in, are there still any questions out there? Do you guys see how to do that now? Good. Okay. Now, as a side note, okay, you're honest, Keely, mostly. It'll take a little practice, okay? I think, you know, as always, math takes practice. So if you just try a few of the problems out before you take your quiz, you'll probably be able to clear up your questions and get it figured out. If you needed to, most of the time it'll be smaller numbers like this, or again, you can take your multiple choice answers, okay, if you have the advantage of multiple choice, take 3 times 3 times 3 and say, okay, does that equal 64? Okay, no, so move on to the next one. Does 4 times 4 times 4 equal 64? Oh, okay, that's my answer. Okay, so that's one advantage if you have multiple choice. The other thing that you can do on your calculator will do a cubed root. What you have to do, though, is write it as an exponent of 1/3. Yeah, that's pretty weird. But that's another way to do a cubed root. So most of us have a not a cubed root, but a square root button. Now, some of you do have a cubed root button on your calculator if you have a graphing calculator. Even if it's just a plain old, you know, a plain old scientific calculator, you'll have a square root button. However, if you didn't have one, another way to write a square root would be an exponent of 1/2. Okay? Oh, there you go. Yeah, if you turn your iPhone sideways, or if you have an iPad, if you turn it sideways, it'll usually have a scientific calculator or like some more buttons. So if you don't hold it vertically, you hold it horizontally, you'll usually see some more buttons show up. Okay, so yeah, if you have, see, there you go, Safa. Yeah, an x square root, that would be where you could put in a 3, and it would do a cubed root for you. So that x is for any other number you want to fill in. Yes, good, good. All right. All right, let's give this one a shot, and then we'll be done. All right, so 3.12, it says cone S is similar to cone T. See, there you go. Perfect, Tristan. There you go. Find the volume of cone T if the volume of cone S is 4,704 pi cubic centimeters. Okay. Okay, so this one is a little bit tricky. Okay. Oh, and you know what else I forgot on here? Oops. I was looking at this like, it seems like we're missing something, and we are. Hang on one second. We need a picture. Let me find that for you just a second. Oh, thanks, Tristan. There we go. Now you guys are with me. And let me grab the picture, because this we can't really do this one without the picture. Almost there. Oh, it won't copy. Come on. Oh, man. There, finally. It took me like 5 tries. There we go. Do you guys see that? Give me a smiley face if you see that picture. Okay. Good. All right. Now you can do it. Okay. Now this one's a little tricky. We haven't done one quite like this yet. Since we're short on time, I'll do it. Okay? So we're going to do, again, we're dealing with volumes. Okay? So we're going to say, okay, volume 2 over volume 1 equals T cubed. Okay? or vice versa. Let's see. So we're looking at cone S. That's the smaller one. It's similar to cone T, which is the larger one. We want to find the volume of cone T if the volume of cone S is 4,704. Okay. So in this particular case, it doesn't matter what goes in the numerator or the denominator, and the reason is because we're actually looking for one of these volumes, okay? So here's what we're going to do. We're going to fill in the volumes. So let's say we'll just call cone T volume 2, okay? So this one would be volume 1. So if we plug that in, we'll just say volume 2. We'll keep that as volume 2 since we don't know it. It's over 4704 pi. Okay, that's what volume 1 is. Do you see that? So volume 2 we don't know. Volume 1 is the volume for cone S. This number here. It doesn't look too pretty, but that's it. Okay, now, we haven't done one like this before. Up until this point, we've been actually finding T. We knew both of the volumes, and we would cube root to find T. Well, in this case, we don't have T. What does T mean? It is a ratio. Good. Ratio of what? Of the sides. Good. Now, let me go back. One more, okay? We did talk about it as the ratio of the sides. What else did I say? You could, instead of the sides, you could also think of it as one-dimensional amount, right? How do you tell? Let's go back to this slide, okay? For example, how do I know that this is a volume? It told me in the problem it was a volume, but if I wasn't told, what in that problem would tell me that it's a volume? What would give me that hint? If I just had this right here, what would tell me it was the volume? 4704 pi. Yeah, there you go. The units, right? Okay. So what tells me in this problem I need for T, remember how I said a few slides back that that's a one-dimensional ratio, something 1D over another thing 1D. Look at the picture. Look at the units on the things that we have in that picture. Do you see some one-dimensional amounts that we have? Okay, now that's not a bad strategy, Tristan. Okay, especially like even if you didn't have maybe, you know, kind of wanted you to estimate, that would be a good idea. Okay, Sarah says, yes, I see some one-dimensional amounts. What are they? Can you guys point to them with your whiteboard tools? Yeah, you got it, Sarah. 24 centimeters and 36 centimeters. Now those aren't an actual side of the cone, that's actually the height of the cone, right? So that's why I am a little cautious there. We definitely can refer to T as the ratio of the sides, but make it a little more broad. Think of it as a one-dimensional ratio. So you need to find something 1D, okay? So if I, on this side of my proportion, put volume 2 in the top, and then I need T cubed over here, so I need some sort of ratio cubed. What would match? Volume 2 comes from cone T. What do you think I'd want up here? Excellent. You guys are getting it good. So I would want 36 over 24. Very good. Okay? So do you guys see how to put that together? So you got to think of, okay, here's my ratio of the volumes, or here's kind of the general rule for it. I fill in what I know and complete the rest as far as what's missing, but think of T as the ratio of one-dimensional something on the picture. Okay, it could be sides, it could be the height, it could be a radius maybe, something like that, okay? So just make sure you, again, match things up correctly, and then we're going to be able to solve this. Now, it doesn't look too pretty at the moment. You know, I don't, no, did you do 36 divided by 24, Tristan? Is that how you got it? And then cube it? That sounds like it's right. Let's see. So if you do 36 divided by 24, I get 1.5 just from that division part. I'm kind of squishing it in down here. Okay, and then I'm going to cube it. Yes, good, Tristan. That's what I got. So I get volume 2 over 4704 pi is equal to 3.375. Okay? Now what do? I want to get volume 2, right? So I got to get that by itself. How could I get rid of 4,704 pi down here? Good. Oh, don't forget your pi, but yes, that's correct. So I'm going to multiply by 4704 pi. Okay, I'll draw a line here to show. I'm kind of running out of room there. Sorry, I'm squishing it in. I hope this is not confusing. Okay, so I'm multiplying each side by 4704 pi. And what's going to happen on the left is it's going to cause that 4704 pi in the denominator to cancel. And I'm going to get volume 2 by itself, which is my goal. And then I'm going to take 3.375 and multiply by, and you can just do, yeah, I think that's what you were saying there, Tristan. Just multiply the decimal by 4704, because if you look at the answers, you want to leave pi in the answer, so don't convert it to 3.14. You would just simply write the pi at the end. Okay, so I took the 3.75, multiplied it by the 4704, and got the 15,876. Yes, there you go, which is B. Phew, we covered a lot today. And I think you guys, for the most part, are with me. Like Keely said, mostly. So if there are any questions remaining, give this one a shot if you can. You know, if you're not obviously listening to the recording and you did testing today, but if you can give it a try before tomorrow. I will have a tutor time tomorrow before I don't see you guys for a week. Okay, so let me know tomorrow if you have any remaining questions on Unit 3, and then, like I said, we have that recording that's already posted in the Class Connect recordings for the test. Okay, so good luck the next week. Send me a KMail if you do have questions. But hopefully you'll get it figured out and you won't need me. But if you do, send me a KMail or give me a call. Probably KMail will be faster for me to respond to you because I'll have my computer with me, but I won't have my phone with me. So anyway, good luck on testing if you haven't taken it already, and good luck on your Unit 3 test.